Hey guys, I'm back with another video. I'm trying to be a little more consistent. So yeah, in this video we'll be walking through different blogs on Medium. Of course, they're gonna be bug bounty related, and we're gonna read each blog. If you're too lazy for it, I'm gonna do it for you, and we're gonna talk about it and everything. So it's like summary of a quick heads up of what happened recently, or just for increasing your knowledge. So let's get into it. Okay, so I got my Medium here, and as you can see, I have multiple blogs here. So I'm just going to choose some random blogs from here, and we're going to talk about it. So let's start with the first one we have, that is blind access vulnerability in profile input that leads to $2,000 reward. Okay, so let me increase the size. Hope it's visible. I was editing my profile on Redacted, okay, a big name company with a bug bounty program. They had a simple field company name, so naturally I made my employer nothing fancy, no recon. What the heck he's talking about? Capture internal admin IPs, cookie data, execution origin, basically foolproof that I had JS execution internal admin panels, the reward. Okay, oh my god, did I just really wasted my time on this? There is nothing in it. What can you learn? I can learn nothing from this article, bro. Literally. Why are you posting this even? Anyone who is posting this kind of blogs, please stop doing that. Literally. Oh my god. Okay, let's move on to another one. Let's say this one. Privilege escalation via manipulation of account attributes. I'm hoping this to be a little better. I don't know. Let's start like any user after logging into the website, which is an e-commerce platform where buying and selling take place. Let's assume the website is called example.com, where you go to the section for purchasing products and add some items to your cart. The first thing that came to my mind is, are there users with higher privileges on the same website? And if there are, how do I identify them? And are they admins, employees, or something else? So this is how the payment method looks like. We have a little screenshot after the cut. So there are two types of privilege escalation: vertical and horizontal. Vertical is where a user gains to higher level privileges than they're supposed to have. For example, a regular user somehow gets admin rights and can control the whole website. Now, horizontal privilege escalation is where a user gains access to another user's privileges at the same level. So it's about same level in horizontal. You're at the same level, you just have access to another user account who similarly have same permission as you. But in case of vertical privilege escalation, you are escalating it in a vertical scenario. For example, you're becoming employee, then you're becoming the admin, and now you have more privileges. So it's like a hierarchy type. All right, now how do we search for them? When I looked at the JavaScript files, I found some parameters. Then I moved to Burp Suite to investigate them further. Yes, I found them in a GET request, especially GET method with the /customer/ID potential IDOR. I spotted these two variables: is employee, is corporate. So I guess there is a Boolean value here. Yep, there is. So is corporate has false, is employee has false. It's always a good idea to change it to true. So, okay, this request here is a GET request. How can I now send a request that changes false to true? What do you think about using the match and replace feature in Burp Suite? Sure, but before you use this feature, do it manually, and if you get a response, then only try to do that work to use that feature, because it will be just a waste of time. But it didn't work. Now let's try sending an options request. So this is the option request. Wow, this endpoint accepts a patch request. Okay. Now we'll send a patch request to /customer/ID while changing the value to true and see what happens. Okay, so value is now true. So he was able to change the value of these two variables. Now let's go back to the website and go to the checkout endpoint. Total order saving. Total to pay. How much was it before? It was 2,000 something and now it's less. Okay, so when it's an employee or is in corporate, they're getting some kind of discount, and the web application was deciding to give that discount based on the value of those two variables. Wow, when I added more products than necessary, it gave me a discount of over 3,000 euros because I was now an employee and not a regular user. Employee does have benefits. I hope you learned something new. Definitely better than the previous one, though. Okay, so why this is happening, because it is not checking the variable values on the server side. For example, it's just trusting the value it is getting from the client side, and then it is using the value to provide discount to the user. It's not validating those values on the server side through the session tokens as well. So if it was doing that, this wouldn't be possible. But that's a nice one. From this, we learned that we should always try to manipulate this kind of variables or attributes. Let's go back. Okay, let me actually give some clap. Let's go back. This one looks good to me. $800 bounty for web cache deception in Shopify. Since we have covered a lot of videos on web cache deception, I think we should definitely give it a read. Okay, so the web cache deception vulnerability on Shopify, one of the world's largest e-commerce platform, was found by this researcher. I'm not going to pronounce this because I don't know if that would be a good or the correct pronunciation. Yeah. So by combining path confusion techniques with a deceptive.css file extension, Golem was able to expose sensitive user data such as full name, email address, profile picture, and valid CSRF token. Okay, by reading this little description, I can tell what happened. This is very straightforward web cache deception vulnerability. Not too fancy. So this is the URL help.spotify.com. So basically a subdomain of Spotify. And this you can see is actually the cache key. This value or this path doesn't exist, but he did a path confusion with .css extension. And then the bot tricks the cache into believing it's a static file, while Shopify backend treats it like 404 error page, which includes personal user data. So this is what happened, guys. If you have seen my videos, you know what I'm talking about. How the server and cache server get confused into rendering or understanding this path. So this basically happens because of normalization. If the backend server is taking this path and it just normalizes it, ignores it, and gives back the response for this URL, which is the correct path/URL, the cache thinks that, okay, this whole path is valid as well. It thinks that it's a valid static CSS file, and then it caches it, which contains the user sensitive information. So this is the step 1. Random string, yep, and then attacker accesses the same URL. No authentication needed. Attacker received the cache HTML with user's private data. So of course, in order to exploit this, you have to send the link to the victim, but it's not going to get cached if the victims open it for the first time. So in that case, you actually have to use an automation script. So basically, you create a script, post it on your local machine or any domain you own, send it to the victim. The victim is going to visit it, and the script is going to run in their browser, and it's going to send multiple requests with this random path, and it's going to cache that value in their browser. Now when the attacker visits this particular path, they're going to get the cached value which was cached by the victim, which contains sensitive information. I hope you're getting it. And we have the mitigation steps here. Avoid caching based solely on file extensions, use content type headers, sanitize for pages and all that. Of course, there's cache control headers. Anyways, so this is one of the basic method, but you can see it also results in a pretty good bounty. Some cases this won't work. In that case, you have to enumerate it or find what files or what extension are getting cached or not, how the server and cache server are normalizing paths, how encoding can help you. If you want to understand those things, go check out my playlist. Nice one. Let's go. I think this is the third one, but more like this is the second one because I'm not going to count this one, really. Let's move on. Okay, how I use the js.map file to get admin access. Let's see what we got here. In the world of web development, source maps.js.map files are incredibly useful for debugging. The link compiled or minified JavaScript back to its original source code, making it easier for developers to pinpoint issues. However, what's boon for developers can sometimes be treasure trove for security researcher. That sounds very AI. Anyways, they can expose entire internal structure of a web application, laying bare sensitive information that can be leveraged for unauthorized access. Okay, when you access a website, the browser typically loads minified or compiled JavaScript files. You must have seen those in the inspect. So these contain API endpoints, data structures and schemas, like the exact structure of data objects, including GraphQL queries and schemas, and authentication mechanisms like how user authentication and authorization are handled, some business logic. But you know what, most of the things is there, indeed it is there, but like a lot of people ignore it or they don't understand it, or even if they see it they don't understand it because these JavaScript files are complex. I think it's a really good idea to give time to it, because if you just look at the JavaScript file and it won't make much sense, but if you deminify it, if you try to read those files, try to search for specific keywords, you'll find something. You'll find some functions or secrets or API endpoints or tokens. Sometimes you even find API endpoints that you don't see while exploring the application. So you find some hidden API endpoints in the JavaScript file. So I think it's really important to read JS files. But yeah. Anyways, unpacking source maps with source mapper. To effectively work with js.map files, specialized tools are invaluable. One tool is source mapper. Source mapper, okay. This is the usage of it. Okay, so you just have to provide the JavaScript or the JavaScript file with the .js.map extension to this tool, and it's going to parse it out for you and save it for you in the folder. Source map is designed to extract JavaScript source trees from source map files. It parses source map typically generated by builders like a Webpack and then recreates the original JavaScript file and their directory structure. Now let's see how it was possible to gain admin access via exposed GraphQL schema. During a penetration test, I discovered an accessible main.js.map file. Using source mapper, I was able to download and reconstruct the entire JavaScript source code of the web application. Bit crazy. Upon reviewing the extracted files, I found extensive details about the application GraphQL implementation. And this GraphQL implementation had mutations and queries, I believe. And I think this is one mutation that is create user with parameters for username, email, and password. Another one is update user role. And then a hidden admin panel. I told you there are hidden stuff. So with the newfound knowledge, I used curl to craft a series of GraphQL queries. Along with curl, you can also use burp suite, of course. I think it's a better idea to use burp suite instead of curl because the structure of GraphQL, it's kind of hard to like put in the curl command, it might give you errors. Burp is more good. So first, he used the create user mutation and add a user to the system. After successfully creating the user, he then leveraged the update user role mutation, setting the newly created user role to admin. In normal case scenario, I don't think they should be able to do that. So this was possible because the js.map file exposed the exact structure and naming conventions needed to invoke the mutation. And the server-side validation was either missing or insufficient. It's missing, actually, to prevent this specific escalation path when called directly via the API. So he was able to find these structures, mutations, and queries. Also, the server was not validating on the server side. This is critical. After successfully upgrading the user account, I could then access the admin panel, perform admin actions, effectively gaining full administrative access, control over the application. So guys, this is vertical privilege escalation. I could also query sensitive data like object names while unauthenticated. This is even crazier. So for more extensive GraphQL vulnerability hunting and dumping, tools like GraphQL Map are also available, which is used for automating the process of finding and exploiting GraphQL vulnerabilities. So this was actually a good read. Something that you can try whenever you see a Minify.js file with this particular extension. This is a bit tedious task because you have to put in the time to read those JavaScript files, everything of it, and maybe you'll find something. Okay. So I'm glad that we only found one bad blog. I was really not expecting that, I swear. I just opened my Medium and okay, let's pick up this one, and damn. Let's move on to another vulnerability. There was this one bug I read about in the morning. I think I put the link somewhere. So I found the link. Here it is. $15,000 bounty for finding a critical vulnerability in Snapchat. I thought to mention this one as well because even though it's a bit simple, but I think it's worth mentioning. So this vulnerability was found in the Spotlight feature of Snapchat. If some of you are Snapchat users, you know what Spotlight is, which allows creators to earn revenue by sharing videos. So it's similar to Reels, TikToks, or Shorts, whatever. Now, a vulnerability allowing someone to delete any Spotlight video remotely could have serious consequences. Basically, you can delete anyone's video by manipulating the ID number. We'll see how. Snapchat uses GraphQL, so these are the steps. Log into your Snapchat account, go to this particular URL, my post, open Burp Suite, capture the request. In the dashboard, select any of your own Spotlight videos and click the delete button. Intercept the outgoing delete request in Burp and it's going to look like this. So we have the delete operation, delete story snaps. This is the name of the mutation. And then we have two variables. First is IDs, and then second is story type. Story type is a Spotlight story, and ID will have a video ID. As you can see, this operation or mutation has these IDs over here, and it's performing the delete operation. Notice the part, the IDs parameter, which holds an array of video IDs. That's why it says IDs and not ID. Replace the ID with someone else. So it's actually possible to get the ID of another user because the IDs of different users are public. So the video IDs exposed publicly in the URL when you view or share a Spotlight video. And this is how the URL looks like. So you can copy the public Spotlight video ID for any user, and then you can put that ID over here, and then you can send this mutation operation. You can forward the request, and the victim video will be deleted even though they are not logged in as them. That's crazy. This is happening because of missing authorization. This is a textbook either. Of course, this was pretty easy to find and to exploit. But again, the main point is to put in the time to it, right? So this one was actually reported in 2023. But yeah, I wanted to mention this one as well in this video. Great. I think we covered 4 blocks. Let's move on to the last one. I hope you're not bored, guys. Should I read this? I went on dark web and instantly regretted it. That will be dark, actually. I'm not going to do this right now, maybe in some other video. How about this one? Most applications let you change your email while profile. So this one is about account logout vulnerability. I'm not sure if you guys know, but as the name suggests, this vulnerability allows you to lock anyone's account if you find it. So let's see. Most applications let you change your email via profile or account settings, yeah, but many of them don't verify whether the new email address actually belongs to you before applying the change. This opens up low-tech but high-impact vulnerability. Something that looks kind of simple but have an impact. So these are the steps to reproduce. Log into your own account, go to the profile or account settings, change your email to the victim email address, which is this, and then save the changes. Now, here's the impact. If the victim tries to sign up, they will get email already exist. If they try to log in, they'll see wrong password. If they try a password reset, they will get no reset link because that email is not tied to your account. In any way, the victim account is now logged out. So this effectively logs the victim out of their own email address within the application. So a nice little bug, that something you can look for. I think something you should definitely look for, actually. Fine. That's it for this video, guys. I hope you learned something from this video. I kind of had fun recording this. And if you want me to make a similar video again in the future, but from your blogs, you can send me your blogs on my Discord or on my X, where I'll read them and review them. So let me know if you're interested. So thank you for watching, and I'll see you in the next one.